So, hello everyone. I am Guillaume Rachet, Head of Product at Perfect Memory. I am specialized in media indexing and semantic technologies for more than 10 years now, and I'm going to share with you the way we see how knowledge graphs and semantic web standards can bring breakthrough features for end users, and especially in the media industry. If you have questions during the presentation, do not hesitate to write it down, and I will answer it at the end of the presentation. So, what we are going to cover during this presentation is first, the need to transform the data to knowledge. What are the stakes of the semantic-driven platform? Two, we will talk, maybe more important, how we can consider to transform the knowledge graph to business user experience. So we will see ontology-driven interfaces in asset management use cases. And then we will talk also how to adapt to business needs evolutions and how we provide an agile configuration of knowledge access for users and processes. So let's start with this market insight. Data is everywhere in different formats. Different because these data are directly related to the tools that build and structure it. So the more business tools you have in your organization, the higher diversity of data forms you will have. And upon that, this raw data does not circulate, stays in separated business silos, and as a raw data is actioned with difficulty. As a consequence, finding the right content is difficult. Data is very often reproduced, or worse, in conflict with each other. Our mantra at Perfect Memory is to say data alone is useless. To address the stakes of multi-sources and formats data and content accessibility, we need to reconcile. So we started to work at Perfect Memory with semantic standards more than 10 years ago. And we believed and still believe that knowledge graphs are the best way to reconcile heterogeneous data because it is standard, it is agile, it is interoperable. So we built our semantic-driven platform, we call it Raffiné, with the ontology as the common context layer for one, heterogeneous data sources and formats ingestion through our dedicated connector framework, we call it Connecte. Two, data processing with potentially AI modules, still through our dedicated connector framework. And three, reconcile data storage with, of course, Ontotext GraphDB. So ontology is actioned everywhere. Data is never alone. We transform the data to a standard information network providing contextualized knowledge. So for all of our clients' projects, we start with the ontology engineering that will structure the meaningful information needed by the operational end user. As an example, for instance, our client France Télévisions, one of the biggest broadcasters in France, we reconciled more than 10 data sources, all related to a TV program, which is a valuable asset. So we consider data that come from the production department, the editorial department, the broadcasting department, etc., etc. So internal sources within France Télévisions ecosystem, but also external data sources like the open data to enrich the existing information, and even the AI modules provided by France Télévisions itself in order to identify specific camera shots, scenes, or displayed objects. By the way, AI modules produce data are a data source like the others, so we need to reconcile it with the rest. So all of this, of course, is reconciled according to the ontology. And here it is. We have a knowledge graph unifying all the data existing or automatically produced, but how business users can action it. So the knowledge graph must bring its added value for the end user. So for that, we deliver the meaningful representation the business users need in their daily work. Remember, the diversity of business tools is directly related to the diversity of data. So you need to provide the knowledge graph through diverse business user experiences. So that way, our end users can search, explore, organize, share their assets through dedicated business views. Let me show you with this iconic multimedia use case. So this is our showroom space. It has been configured in order to demonstrate several use cases for media business users. So we ingested many asset types, such as textual document, pictures, sound, videos. And if we go, let's jump, for instance, on this example. We have here a TV program, just like the France Télévisions one we saw earlier. So we have this TV program. Behind this, we have the knowledge graph. And from this knowledge graph, we can see the relations, the properties between this video program and all the connected information. And for each of them, we keep the trace of the source of this information. It can come from the external, it can come from AI modules that has automatically generated it, and it can also be added manually by the business end users. The key thing here is that we all know in knowledge graph, each connected resource is also a strongly typed entity. So potentially enriched by other data sources, such as Wikidata in this Monaco example. And we have the ability to navigate from this meaningful entity to connected assets. And again, through relations that directly come from the knowledge graph. So it brings exploration features for the end users in a much more precise way in comparison to keywords and classical metadata indexing. But more, all of this is actioned for search purpose. If I go back on the main search interface, if I search for Joker, Joker can mean many things. It is a character, it is a movie, it is a cartoon. So the idea is to consider that the knowledge graph can also be action for filtering, for search filtering purpose. So you have here, for instance, the ability to filter, okay, I want to search, or I will go back again on my search. Yeah, I can action Joaquin Phoenix, for instance, as a meaningful entity connected to the assets. It is actually connected to all the results I will obtain. So it's a direct relation between my assets and the meaningful information. But more important, we can action the knowledge graph at any level of depth. For instance, if I show you that if I filter on, let's say, Italy, I will obtain some results that are not directly connected to Italy, but are actually connected to here Venice, which is a city in Italy. So again, thanks to the knowledge graph approach and this information propagation mechanism, we deliver to the end users the ability to multiply the entry points to the content, and so to have easy access on any asset in order to use it in a production context, to broadcast it, to share it, etc., etc. So this propagation mechanism, we know it well in the knowledge graph area. This is the inference mechanism. And this inference mechanism can be action for specific business entities. For instance, the rights, the editorial rights attached to the contents. Let's show an example for that. If I show you, for instance, this other TV program, again, you can see here several information attached to this TV program. And you can see in the bottom part that editorial rights are attached to the content. But more important, you can see that, for instance, this warning, I must blur the little girl with the pink bag in the background. It's the result of an inference mechanism. It's an inferred right. So you don't have this information directly attached to this video program. It comes from another connection from the graph. And in this case, it means that this video program contains broadcasted stories. So during this event, this program, these stories have been broadcasted, and this one especially carries the rights issue. And in the same way, you can see that on this video story, the right has also been inferred. So if I go in the details of this video story, I can have a look on the video rushes, the video shots that have been used by the video editor. And we can see that the warning actually comes from this video rush. So thanks to this business user interface that actually action the knowledge graph behind this, we help the end user to avoid mistakes, to broadcast content that cannot be broadcasted. We enable the end user to be relevant, so for their broadcasting needs, but finally to take better decisions. So we deliver these key features as we saw it for search, exploration, but we also use it for documentation purpose. If I go on another example, if I search for this content, if I go within it, again, I have several information attached to the content. As an archivist, I have the ability to add information to this content with validated knowledge, such as, for instance, IPTC categories or meaningful entity types, etc. So I have this ability as an archivist to connect my asset to validated knowledge in a general way, but more important, I can do it within the asset itself. So in this content, which is a video, I have the ability to, let's say, choose a criteria, a meaningful entity criteria, and to jump from this criteria to another, to another. The idea that this meaningful navigation within the content help the user to very quickly identify a specific content. But as an archivist, I have ability, if I need it, I can add myself a new tag. And let's say I want to tag that on this shot, we have a cloud. And by cloud, we surely mean that it's not the cloud computing, but the cloud in the sky. And so if I search for cloud, I have the ability to add more and more tags, and finally, as an end user, to action it again for search purpose. If I search, for instance, mountain, and I cross it to cloud, I will have the ability to directly get my result, the specific result, inside the content. So we bring key features for end users in the media industry to manage their assets. A fully ontology-driven business user interface to manage assets. And we call it the cognitive asset management. Okay, so let's go back on the presentation and let's talk about how does it work to adapt it to different contexts. You just saw an example with our showroom space. You saw an example of an entire configuration ontology, business views during this demonstration. And again, we deliver configuration interfaces in a fully ontology-driven approach. It enables to always feed the business needs. If the need evolves, the ontology surely can, and so does the configuration of the business views. So it enables our clients to, let's say it that way, to master their knowledge supply chain. We can access the ontology directly from the interface, enabling data and AI departments to follow the command model for each step of the configuration. All of this, we call it the asset context engineering. So do not hesitate to contact us if you want a detailed demonstration on these integration features. So in order to solve, let's say, the main struggle we identified of the market, Perfect Memory consider these key takeaways. We improve asset management, accessibility, reusability by injecting ontologies even in interfaces. The combination between knowledge graphs and business interfaces deliver the highest value for business users. And as a reminder, AI is a data source like the others, and so must be contextualized in the same way. So to conclude with a few words about Perfect Memory, we deliver, as we saw it, the cognitive asset management solution as a collaborative and evolutive solution to manage operational users' assets by their own rules. And we deliver to data and AI departments the asset context engineering as an interoperable and agile solution to engineer the asset exploitation model according to their end users' needs. So we have today several clients in the media industry, such as RTL, France Télévisions, we saw it, M6, or the Paris Saint-Germain Football Club. And all of them action semantic graphs without necessarily knowing it, but witnessing daily its breakthrough added value. So you can have a look at precious insights that are available on our website, perfectmemory.com, with several use cases from media industries, but also in other domain. So thank you for your time, and I am available for your questions if you have some. Thank you. I don't know if there are some questions. Yes. What's the reasoning behind cognitive assets? Is there a distinction from semantic assets like ontologies? Yeah, that's a very good question. Thank you, Maggie. So what we call the cognitive asset management is to deliver the capabilities for the end user to benefit of, let's say, cognitive features. And by cognitive, we intend to cover the combination between semantic approach, so semantic standards, knowledge graphs, semantic technologies, including the reasoning capabilities. But you also have the collaboration between data sources. So this ability to reconcile data based on business rules and also the collaboration between AI modules. Because if you want to deliver enrichment on the data, processing on the data, you will need to make these AI modules collaborate. And so the cognitive aspects of the solution is the result of all this combination. The automatic processing that come from the AI, the reasoning capabilities, and we can say this collaboration between statistical AI and the semantic AI. So yeah, what we mean by cognitive is all of this. I hope I answered to your question. Do you have other questions? Okay, Yasen. I don't know if you still have your technical issues on your side. Um, okay. Okay. So I can conclude myself and say thank you very much, all of you. Do not hesitate to visit our virtual booth. We are available to answer any questions you may have in the next hours and tomorrow. So thank you again for your intention and see you in the next sessions.